Hi everybody. Today we're going to talk about solving systems again, and this is kind of the cap to the solving systems part of the unit. We're going to do something new. It's a little different. It's called solving systems using matrices. You say this word matrices. This is the plural form of the word. If you were going to say it in a singular form, we would say matrix. Yes, like the Matrix and Neo and yes, that. But matrix is the singular form, matrices is the plural form, kind of like vertex and vertices. So today we're going to talk about how to solve systems using matrices. I am going to ask you to go to Desmos in a moment. But for right now, let's just kind of talk about what this means. So systems of equations can be written as matrices. The matrix equation is an equation that contains the coefficients and the constants from the system of equations. And they'll be put into matrix A. Notice that there are brackets around a capital A. That's the way that you write the name of a matrix. So matrix A is its name. So, before we talk about how to write the matrix equation, we first need to talk about dimensions. So when we talk about dimensions, think about a room or a rectangle, and we talk about the dimensions as in like the length and the width, and typically of a two-dimensional shape, we talk about just two of the dimensions. So here we're going to discuss the dimensions for this matrix. It says what dimensions would be used to put this system in the calculator or in Desmos as a matrix. Well, the dimensions are the number of rows. That's the first dimension. By, so a little x means by, rows by columns. That's not how you spell columns. Hang on just a second now. There we go. Okay, so a matrix is the number of rows by the number of columns. So if I'm talking about the number of rows in this set of equations, in the system of equations, I have 1, 2, 3 rows. So it's a 3 by something. And the number of columns, remember we talked about the matrix equation involving the coefficients and the constants for the system. So notice how kind of like an elimination, all of the terms are aligned. So all the x's are on top of each other, and all the y's are aligned, and all the z's are aligned, and all the equal signs are aligned. And then over here, the 6, the 3, and the 5, those are the constants that also appear in the matrix equation. So if I'm talking about the number of columns, then I'm talking about the x's, the y's, the z's, and the constants. So how many columns is that? That's 1, 2, 3, 4 columns. So the dimensions of this matrix are 3 by 4. Now, all of the writing that I have here is going to kind of get in the way, so I'm going to go ahead and erase it, but it's important to know that dimensions are always the number of rows by the number of columns. This happens to be 3 rows and 4 columns, so this is a 3 by 4 matrix. So let me go ahead and erase this up here so that it doesn't get in the way of what we're doing today. Okay, so it's important to be able to write the dimensions. It's also important to be able to write the matrix equation. So what we're going to do is we're going to pick out all of the coefficients and the constants for these systems, or for this system, I'm sorry, and we're going to put them, organize them into a matrix. Now here, it looks kind of rounded. Okay, so sometimes you're going to see a matrix in kind of like this rounded set of brackets here, but sometimes you will also see it in just like square brackets, just like that. So you will see one or you will see the other. When I write my matrix equation, let's look at the first equation in my system. My coefficients are -9, positive 3, positive 1, there's an invisible 1 there, and then my constant is a 6. So negative 9, 3, 1, 6. Negative 9, 3, 1, 6. In the next equation, my coefficients are 10, this is a 1, this is a negative 1, and the constant is 3. So 10, 1, negative 1, 3. 10, 1, negative 1, 3. Now, solving systems by matrices is not difficult, but the most common mistake is going to be you incorrectly writing the matrix equation because maybe you skip a number or you get a number in the wrong place. So really pay attention and focus as you write these constants and coefficients into your matrix equation. So go ahead and do the last one. And notice, let me go ahead and change colors here. Notice that all of these first terms coincide with this first column in the matrix, and they're all x coefficients. You notice that? The second one comes from all of the coefficients of the y terms. So this is all the y term coefficients. This is all the z term coefficients. And this is all of your constants. Okay? So I'm going to scroll down. We're going to talk about how to use this matrix equation to solve the system. Here we go. There. All right. So the first thing that you're going to do is you're going to go to desmos.com/matrix. /matrix, singular. You may have to log in with your district credentials, so I'm going to give you a moment to do that. Come around to the other side of my computer. Open up a new tab. Type in desmos.com/matrix. And I'm not signed in yet. It looks like I don't need to sign in, so that's kind of nice. So second step, after you sign in to desmos.com/matrix, is you want to select a new matrix. So see this button right here? I'm going to select New Matrix. Notice that we have a name for the matrix. This is matrix A. And notice that we have these brackets over here. Also notice the dimensions of this matrix. This matrix has 2 rows, 1, 2, and it has 2 columns, 1, 2. So this would be considered a 2 by 2 matrix. Notice also that I have the number of rows and columns listed here under Edit Matrix A. So step 2 was to select new matrix. Step 3 is to edit the number of rows and columns to match your problem. So we're going to use the example above. Remember that this was a 3 rows and 4 columns matrix, so it was a 3 by 4. I'm going to change this to have 3 rows and 4 columns. Notice how it kind of bumps up the number of rows and columns in your matrix. Still called matrix A. So we edited the number of rows and columns that matched our problem. Step number 4 is to type each element into your matrix. This is where the mistakes occur, and we don't want the mistakes to occur here. Now, I know that you're probably not splitting your screen right now, but you might want to because you're going to have to look back at your matrix equation so that you can type these numbers into the correct space. So the first row had coefficients of -9. Arrow over to go to the next space, 3, 1, and a constant of 6. Now I'm going to arrow down and back over to the left to type in the next row's entries. So 10, 1, -1, and a constant of 3. And then finally the third row we have coefficients of 5, 9, -2, and a constant of 5. I might have said constants of 5, 9, and -2. I meant coefficients. Okay, so all of our terms are entered where they're supposed to be. I'm going to just kind of spot check and make sure that all of my numbers are in the right spot, and it looks like they are. It's a good idea for you to do that too. So we've typed in each element into our matrix. We want to press enter, and then we want to press something called Rref. So we want to press that. So I'm going to hit enter, or I can hit this little button right here. Oh, I'm sorry. There we go. And then Rref is down here. So I'm going to press that. I've got to go back to my instructions. And then step 7 says select your matrix name. So look above for the name. It's most likely matrix A, and then press enter. So I look above, I see matrix A. So I'm going to, in my parentheses, either type or press the letter A. And then I'm going to hit enter. And honestly, if you don't hit enter, that's fine, because what you want is what appears over here on the right side. Notice that it is also a 3x4 matrix, but it's a different 3x4 matrix. And notice that we have 1s in the diagonal here, and we have 0s in a lot of the other places, except the far right column has a whole bunch of numbers in it, 1 and 2 and 9. So let's talk about what that means. The right side of our screen has what's called the solution matrix. So it's a matrix of the same dimension as our matrix equation, but it's called the solution matrix. And so what does this mean? Well, what this means is that these values that are over here, 1 and 2 and 9, that make up the last column, that contains all of your answers. Your x value is equal to 1, your y value is equal to 2, and your z value is equal to 9. The way that I know that 1, 2, and 9 belong to x, y, and z, respectively, is because remember this first column right here? That was all of your x coefficients. So the only place that there is a x coefficient of something other than 0 is right here. That means that this answer is your x. Here, this was your y column. So there's a 1 right here. That means that the y is equal to 2. And this was your z column. That means that your z answer is equal to 9. So typically you want to go ahead and write your answer as an ordered triplet. Usually we call this an ordered pair, but because we don't have x comma y, just a pair of numbers, we have 3. We call it an ordered triplet. So x comma y and then comma z. It's basically an ordered pair with just an extra number. So your x value is 1, your y value is 2, your z value is 9. Okay, so let's scroll on down. And actually, if you want to skip this part of the video, that's okay. I'm not sure where you should pick up, but I do want to show you a little something. And I thought about not showing you, but I think it would be beneficial. Let's talk about that equation right there. Remember that those numbers are the coefficients and the constants. So if I am looking at this row, the coefficient is 1x plus 0y plus 0z's equals a constant of 1. Well, if this is my equation that's created with that first row, 0y's and 0z's get canceled out, and you have x equals 1. And that's how I get my answer of x equals 1 here, because each row creates an equation. So I just wanted to point that out to you, that that's how I know that it's my x value that equals 1, and my y value that equals 2, and my z value that equals 9, because we can create those equations. Okay, so let's look at example 1. Example 1 says, set up the following system as a matrix equation and solve. So I have x's on top of x's, I have y's on top of y's, I have constants on top of constants. Everything is aligned, kind of like for elimination, But here I need to write my coefficients and my constants in this matrix equation, which, by the way, there are 2 rows and 1, 2, 3 columns. So this is a 2 by 3 matrix. So my top row, my coefficients are 4 and 3, and my constant is -4. In my bottom row, my coefficients are 3, and this is a -1y, so -1 is the coefficient, and the constant is -3. Now, if I'm going to find my identity matrix, I need to go ahead and go to desmos.com/matrix. I need to clear out everything. I want to select new matrix. My matrix is not 2 by 2. My matrix is 2 by 3. I'm going to type in my elements of the matrix. Ooh, not sure what happened there. Just a second. Okay, well, we'll just leave it there. So my elements of the matrix, the first row are 4, 3, and -4. So 4, 3. Oh my goodness. Just a second. Four, 3, and -4. And then the elements of my bottom row, go ahead and type those in. 3, -1, and -3. Oop. Spot check. Looks like this middle one I need to type in a 3, so that got messed up whenever I was having trouble with my computer. I press enter. I go to Rref. I want to reference the name of the matrix. This is matrix A. There's my identity matrix. So my first row is 1, 0, -1. And my second row is 0, 1, 0. So I have 1, 0, -1, and 0, 1, 0. Remember that your first column was your X column, and there's an X here, which means that X, 1X, plus 0Ys equals -1. So X equals -1. And then for your second column, these are your Ys. So the second row has no X's plus 1Y equals 0. We have Y equals 0. So I would write my solution as there are only 2 numbers here, so I'd write it as an ordered pair, -1, 0. All right, let's look at part B. I want you to pause the video. I want you to try to write the matrix equation and then come back and check, make sure you got it right. So check your matrix equation with mine. Notice that in the third equation, the third element doesn't appear. There are no z terms in this place right here. So we put plus 0z, and 0 becomes the element. Now I want you to pause your video, go to desmos.com/matrix, and I want you to try to find the identity matrix. Pause your video. Okay, so go ahead and check your identity matrix. Remember that this first column was your X coefficients. The second column was your Y coefficients. And your third column was your Z coefficients. So you're looking for the 1s. If you have a 1 right here for the X column, that means that X equals 4. If you have a 1 right here in the Y column, that means Y equals 3. And if you have a 1 right here in the Z column, that means Z equals -1. And you can write your answer as an ordered triplet of X, Y, and Z. That is your solution. Okay, so I'm going to go ahead and scroll down to our next problem. So in example 2, it says a change machine contains nickels, dimes, and quarters. There are 141 coins in the machine, and the value of the coins is $18.75. There are 3 times as many nickels as dimes. Define your variables, write a system of equations to represent this, write a matrix equation, and then solve to find the number of nickels, dimes, and quarters the machine contains. So there's a crazy amount of information that occurs in this problem. The first thing that it asks us to do is to define each variable. So when I define the variables, I need to put the letter, the variable, and then I need to put what it's representing. So this change machine contains nickels, dimes, and quarters. So I'm going to make my variables N for the number of nickels, D for the number of dimes, and Q for the number of quarters. Be careful to make sure that your Q's don't look like 9s. That happens sometimes, and then students get confused. So it helps to have like this little loop on your Q. Or if your Q's don't look like that, just make sure they don't look like 9s. So the equations. There are 141 total coins. So the number of nickels plus the number of dimes plus the number of quarters equals 141 total coins. So this equation is all about the coins. The next information that it gives us is the value of the coins. The value of the coins is $18.75. $18.75. That's the value. But I need to have the values of the nickels, dimes, and quarters on the left side of my equation. So the nickel is worth 5 cents. So 5 cents per nickel plus 10 cents per dime, or 0.1, plus 25 cents per quarter. And then the last bit of information that we have is a relationship. So there are 3 times as many nickels as dimes. So there's way more nickels than dimes. That means that I'm going to have to take 3 and multiply it by the smaller number, which would be the dimes, so that you can get the bigger number, the nickels. Now this relationship here doesn't really fit with the N and D and Q and equals and constant that I have going on in the first 2 equations. So I'm going to rearrange this so that the N and the D variables are on the left side of the equal sign, and I can have a space for N, D, Q, and a constant. So I have 3D equals N. I want N to go to the left side of the equal sign, just like in my other equation, so I'm going to subtract N from both sides. I have 3D minus 1N plus how many quarters? Q doesn't even appear in this equation, so no quarters equals. And then there's nothing on my right side because N minus N is 0. So that's my equation for the relationship between these nickels and dimes. So now I'm going to create my matrix equation. My matrix equation is a 1, 2, 3 by 1, 2, 3, 4. So it's a 3 by 4. My matrix equation has a top row of coefficients of 1, 1, 1, and 141. So 1, 1, 1, 141. My middle row has a lot of decimals. So 0.05, 0.1, 0.25, and 18.75. And then my third equation is the one that I had to kind of reorganize. So, oh man, I almost wrote, this is what I almost wrote. Don't write it because it's wrong. I almost wrote this. Why is that wrong? Think about it. Why is it wrong? What is my first column representing? My first column represents in, but the 3 is not a coefficient for n. The 3 is a coefficient for d. So I should have changed these around. And that almost cost me the right answer to this problem. So -1n plus 3d plus 0q equals 0. So I need to change this up a bit. I almost messed up the whole thing because I wasn't paying attention to my order. The first term is an n coefficient. The second term is the d coefficient. The third term is the q coefficient, which is 0, and then the final term is the constant. So I've got everything written out the way that I should in my matrix equation. I need to find the identity matrix using desmos.com/matrix. I need the number of nickels, dimes, and quarters, and it would make no sense to write this as an ordered triple. I need to write my solution in sentence form because the information was presented to me in sentence form. So I am going to do the last one with you because I want to make sure you see this one more time. I'm going to go into desmos.com/matrix. I'm going to clear everything that's there. I'm going to add a new matrix. The matrix that I want for this problem is not 2 by 2. It's 3 by 4. So I'm going to increase my rows and my columns. I'm going to type in my coefficients and constants. So my matrix equation, I had 1, 1, 1, 141. I had 0.05, 0.1, 0.25, 18.75. And this is the one that I almost messed up on. I have -1, 3, 0, 0. So I'm going to press enter. I want to reference matrix A. So there is my identity matrix. Notice how it has numbers on the right side, a diagonal of 1s to identify the variable, and 0s everywhere else. So I'm going to go ahead and write my identity matrix. My top row is 1, 0, 0, 66. My bottom row is my middle row is 0, 1, 0, 22. And now my bottom row is 0, 0, 1, 53. Remember that my first column was my coefficients for n. Second was coefficients for d. Third was coefficients for q. So that means that my number of nickels is 66. My number of dimes is 22. And my number of quarters is 53. No ordered triples for this problem because it was a word problem. So there are 66 nickels, 22 dimes, and 53 quarters.